Hello everyone. In this video, I'm going to talk about what we learned in this week's lecture. So, yeah, we dived a little bit deep into how machine learning model actually learn. So, while previous weeks we focused about using models of black box and everything, but this week we opened them up to understand the underlying mathematical foundations, focusing on linear regression, gradient descent, and logistic regression. The understanding these mechanics is vital because it helps choose the right algorithm and set the best hyperparameter for a specific data set. So, yeah, the core of the lecture was linear regression, where we learned that a model makes prediction by computing a weighted sum of input features. To train this, we need to minimize the error, usually measured as root mean square error. So we also explored many ways to find the best model parameters versus the normal equation, which is a mathematical shortcut to get the result directly. And the second is gradient descent. So the lecture also used a great analogy. Imagine being lost in a thick fog on a mountain. Your best bet to find the bottom is to feel the slope under the feet and move downhill. So we looked at three versions: bad GD, stochastic GD, and mini bad GD. So another key takeaway was also handling nonlinear data using polynomial regression, where we add powers of features as new features. However, this led to discussion on overfitting, where a model performs great on training data but fails on a new data because it's essentially memorizing the noise. So to detect this, we also learn using learning curves. Yeah, there was a large gap between the training and evaluation area. The model is overfitting. So to fix it, we use regularization techniques like RIZ and lasso regression. Lasso is particularly interesting because it tends to set the weights upon important zero features to zero, effectively performing feature selection for us. So finally, we moved on to from regression to classification with logistic regression. Unlike linear regression, it uses sigma function to output a probability between 0 and 1. We saw this in Axon with the iris dataset. Yeah, and then also we learned there was some challenging aspect, some of which was, like bias or variance trade-off. It's a delicate balance, increasing complexity, reducing bias, but increasing variance, and vice versa. So the most interesting part was early stopping. It's such a simple but brilliant idea. You know, to stop training the moment the validation error hits a minimum to prevent overfitting. So yeah, overall, yeah, this week provided why and behind the how of the machine learning, which I know will be crucial as we move into the more complex neural networks. Thank you so much for watching.